let's try to understand one question which is important for buoyancy and flotation. The large vessel shown in the figure contain oil and water. A body is submerged at the interface of oil and water such that 45% of its volume is in oil while the rest is in water. The density of the body is what? What is given? So this figure is given in this question, and the information which is given, the specific gravity of oil which is equal to 0.7 and the density of water is 1000 kg per meter cube. Acceleration due to gravity g, that is equal to 10 meter per second square. So this is given in this question. You have to find out the density of the body. So this is the body here, and this body is submerged in oil air water interface. So you have to find out the density of the body. So how to calculate that? So we know that weight of the body that is equal to buoyancy force. So what will be the buoyancy force? The buoyancy force due to the oil plus the buoyancy force due to the water. Okay. So what is the weight? Weight of the body that is equal to rho of the body into g into volume of the body, that is equal to what is the buoyancy force for oil, that is rho of oil into g into 45 by 100 v, which is given in this question. So 45% here, 45% of its volume is in oil and rest is in water. So 55% is in water. So that's why rho into 45 by 100 plus rho of water into 55 by 100 into v. So v is common from both sides and g is also common from both sides. So from here, rho of b, that is equal to rho of oil into 45 by 100 plus rho of water into 55 by 100. So from here, rho of b, that will be, so rho of oil which is given because the specific gravity of oil, that is given 0.7. So what is the density of oil? That is, you have to multiply it by 1000, so that will be 700 kg per meter cube. Okay, so here the density of oil, that is 700 into 45 by 100 plus what is the density of water, that is 1000 into 55 by 100. So from here you can get the density of the body, that is 865 kg per meter cube, and this will be the answer. This is very important question for GATE point of view. Remember this question. Now one important topic which is also important, that is the concept of apparent weight or net weight. So what is that? The weight of the body measured in air is the real weight, but in another liquid or fluid is apparent weight. So here suppose this is any person is there, and the weight of the person, that is mg, okay, in air. So now this person is in another fluid. Okay, so weight of the body which is acting downward direction, and there is a buoyancy force which is acting upward direction. So what is the apparent weight? Apparent weight will be mg, weight of the body, minus fb, buoyancy force. So mg minus fb, that is mg minus fb, that will be the apparent weight of the body. So remember this, very important. Now let's try to understand one important question that is very important for GATE point of view. What is given in this question? The cross section of an object having same section normal to the paper submerged into a fluid consists of a square of side 2 meter and triangle as shown in the figure. So this figure is given here. The object is hinged at point P, that is 1 meter below the fluid free surface. If the object is to be kept in the position as shown in the figure, the value of x should be what? So you have to find out the value of x. So this is given in this question. So here this is the free surface here, and this is the height, that is 2 meter, which is given, and length is also 2 meter, and x is not given, and from here to here the distance is 1 meter. Okay, now you have to find out what is the value of x. Okay, now let's try to solve this question, very important question. So this is my handwritten notes. You can download it from the description. Like, share and subscribe my YouTube channel. So let's try to solve this question. So here, so this is given in this question. So here this is the body here, and this is 2 meter. Consider the width of the this is b, and this is 2 meter which is given. This is x, this is also given, and this is 1 meter. Okay, now so here what is the buoyancy force? So buoyancy force here, that is this point, consider this point is B1, and here the weight is acting from this point, and buoyancy force will be upward direction. So suppose this is B2, so buoyancy force, that is FB2, that is upward direction, and weight of the body, that is W2, that is downward direction. Now for equilibrium condition, if you take the moment about P, so this is the point P here, this is the point P, and if you take the moment about P, that is equal to 0, so FB minus W, so in this point FB is the upward direction and W1 is the downward direction, so FB minus W1 into, what is this distance? This is 1 meter distance, so you have to take a moment about P, so that's why the resultant force into perpendicular distance. So what is the perpendicular distance? That is 1 meter, so into 1, that is equal to, so here the FB2 is upward direction and W2 is downward direction, so FB2 minus W2 into, what is this distance? So this distance will be x by 3, because this is x and this is the triangle, so here to here, so here to here the distance will be x by 3, so this is x by 3. So from here V1 is common from this side, so omega of F, omega of fluid minus omega of the body into V1, that is equal to omega of fluid minus omega of body, that is into V2, that is into x by 3. So from here you can get V1, that is equal to V2 into x by 3. Now what is the value of V1? That means volume of the section. So in that section, what is the volume? That is 2 is given, 2 into B. So 2 into B, so that is the volume V1 equal to, what is the volume of V2? So this is volume V2, so half into base into height. So half into base, what is the base? That is 2, and the height, that is x, and the depth will be B. So that into x by 3, which is given in this question. Now x square, that is equal to 12. So from here x equal to 2 root 3. So this is important question for GATE point of view. So if you have any doubt in any question, you can directly ask me in comment box. So you can download it, this notes from the description page. If you have any doubt, any question, you can directly WhatsApp me or email me. My email address is paria9733@gmail.com. You can directly email me, and if you have any doubt, any question, you can directly comment on this video. So like, share and subscribe my YouTube channel. Thank you.